Together, Karen and Doug can clean a strip of beach in 5 hours. Alone, Karen can clean the strip of beach 1 hour faster than Doug. Find the time each person takes to clean the strip of beach alone. Give an exact answer and a 1 decimal approximation. When it says approximation, I'm going to assume that's going to be irrational, so we'll probably need the quadratic formula. But we need the time it takes each person to clean the beach. That's what we don't know, so let's look at this. Karen and Doug and together. Okay. So together they can clean the strip of beach in 5 hours. So they can do 1/5 as their rate of cleaning the beach together. Alone, she can clean the strip of beach 1 hour faster. So it will take her less time. So we can either look at that as 1 over x and 1 over x plus 1. Or you can look at that as 1 over x minus 1 and 1 over x. Either way, that'll work. I'm just going to use the first way since I wrote that first. But either way should work so that it takes her less time because she's faster. 1 hour faster. So it'll take Doug 1 hour more to do the same job. Okay. Well, this is a rational equation, so that means we're going to need a least common denominator. We have a factor of 5, a factor of x, and a factor of x plus 1. We'll need all of those in our least common denominator. So 5x, x plus 1, we're going to multiply to every term in this equation. 5x, x plus 1. So that we can cancel out the denominators. Okay, and let's see what's left. For the first term, 5 times x plus 1 times 1, so 5 times x plus 1. For the second term, 5x times 1, 5x. On the right side of the equation, that leaves x times 1 times x plus 1. So we got some distribution we'll have to do here. 5 times x, 5x, 5 times 1 is 5. And on the right side, x times x is x squared, and x times 1 is x. So this is a quadratic equation. I probably want to combine those like terms before I start moving things, moving terms to the other side. So this is not just 1 square equals a number, so I'm going to have to get 0 on one side. Let's subtract the left side. So minus 10x minus 5. So 0 equals x squared minus 9x minus 5. And I did say that we'll probably need the quadratic formula because they ask us for an approximation. Yeah, there's no factors of 5 that adds up to 9. So let's use the quadratic formula. A is the coefficient of x squared, b is the coefficient of x, and c is the constant term. So we're solving for that middle variable. X equals negative 9, so that's positive 9, plus or minus the square b squared minus 4 times a times c, all over 2 times a. Okay. Let's simplify what we have in the radical. A negative 9 squared is 81. There's 2 negatives, so that'll be plus. 4 times 1 is 4 times 5 is 20. And in the denominator, 2 times 1 is 2. We can add together 81 plus 20, that's 101. And whether that simplifies, I need an exact answer. So I do need to know if that simplifies 101. Let's see what that divides to. I don't find any factors of that. So this is as simple as it gets, but there's 2 answers. There's 9 plus root 101 over 2 and 9 minus root 101 over 2. And we know that one of these is not going to make sense since the root 101 is larger than 9. That's going to be negative, so that answer is discarded. So let's see. We have two people, Karen and Doug. So Karen's rate is x. So that is exactly 9 plus root 101 over 2. Approximately 9.5, how many decimals? Just one. So 9.5. And this is hours. 9.5 hours. Doug then is going to be one more. So 1 in halves is 2. So 2 halves plus 9 is 11 halves plus root 101 over 2. And that should be 1 hour more, 10.5. So check that in the calculator and make sure. And that works out. So that answers the question for how long it takes them to clean the strip of beach by themselves. A family drives 100 miles to go camping for vacation. The return trip was made at a speed that was 10 miles per hour faster. The total traveling time was 3 2/3 hours. Find the speed to camp and the return speed. So those are the things that we don't know, these two speeds. Let's see what we do know. They're talking about miles, speed. So distance, that's rate times time equals distance. That's how I know what we're working with. We've got 100 miles to go camping. So that's the distance to vacation and the distance home, right? The return trip was made at a speed that was 10 miles per hour faster. So whatever this rate was to the vacation, the return speed is faster by 10 miles. The total traveling time was 3 2/3 hours. That's not the time individually, that's the total time together. So 3 2/3 hours. Probably want to get that into an improper fraction, so 3 times 3 plus 2 is 11/3 hours. So hours, miles per hour, and miles are our units. Find the speed. Okay, we know that rate times time equals distance, and we don't know what the time is. That's what we have to figure out here, so let's divide by the rate. And the time is distance over rate. So distance over rate. And we have a total time, so that means add the times together to get the total. So the time to the vacation plus the time for the return trip equals the total time of the vacation driving time, which is 11/3 hours. So this is a rational equation. We're going to need a least common denominator here. We have a 3, an x, and an x plus 10. So let's multiply that out. So 3x times x plus 10 multiplied to the first term. 3x times x plus 10 to the second term. And on the other side, 3x times x plus 10 here. That's going to cancel out the denominators. X plus 10, and 3. And let's see what's left in the equation. So for the first term, 3 times 100 is 300 times x plus 10. For that second term, 3 times 100 is 300 times x. And on the right side, 11 times x plus 10. Those are all left. So we've got some distribution to do here. That's 300x, add another 0 to get 3,000. On the right side, that's 11x squared plus 1 with a 0. Okay. So this is quadratic, but I've got like terms that I want to combine first. That's 600x plus 3,000. Equals 11x squared plus 110x. Sorry about that. It was 110 times x. Okay. So now I want to get all of my terms on the right side. So I'm going to opposite the left side terms, minus 600x minus 3,000. Because then we'll have 0 on the left. Equals 11x squared. Combine those together. Minus 490x minus 3,000. Wow. I hope I can divide 11, but it doesn't look like it divides by those terms. So it looks like we're going to be using quadratic formula. We're solving for this middle variable. We've got A, that's 11, B is negative 490, and C is negative 3,000. So negative B is positive 490, plus or minus the square root of negative 490 squared minus 4 times 11 times negative 3,000. Those are some big numbers there. All over 2 times 11. Let's simplify what we have. 490 squared is 240100. There's 2 negatives, so that'll be plus. 4 times 11 is 44 times 3,000. That's 132,000 all over 22. So let's add together under the radical. 372,100 altogether, which actually is a perfect square. So we could have factored this, but those numbers were so big I wasn't feeling confident about that. The square root of 372,100 is 610. So we'll have 2 solutions here. The 490 plus 610 over 22, and the 490 minus 610 over 22, which will be negative. Is that okay? Nope. Speed can't be negative, so we will only do the plus. So 490 plus 610 is 1,100 divided by the 22, which is 50. Does that make sense? Let's go back and see what that stood for. Okay, so 50 is the rate, miles per hour to the vacation. Then the return trip would be 60 miles per hour. That seems very reasonable. I can always double check that in my equation if I plug in the 50 and 60, see if that works for the distance. So 50 times 100 divided by 50, which is 2, equals 100. Yes. And the same thing with the return trip to make sure that that is correct.